Thank you for joining us in our lecture today for Engineering Design 1. We are group number 9, designing a prosthetic arm. My team members are Renato Soto, Kevin Vegnas, Ryan Bates, and myself, Chris Paredes. And in this lecture, we're going to be talking about the project summary, the proposal, the usability, system overview, materials, and responsibilities that each team member is going to have in this project. A little backstory for this project. In the beginning of the semester, we were putting out ideas on the table, trying to decide what we were going to do, and one of our team members was very passionate for this subject, and his name is Renato. Renato is very passionate about designing prosthetic arms for those who are less fortunate, and so we decided we're up for the challenge. So for this project, we're going to be designing a prosthetic hand designed to mimic the human hand, to function just as your normal everyday hand. And how we're going to be demoing out that prosthetic hand is we're going to be using a glove to connect to a user to control that prosthetic hand to mimic your normal hand. Once we get that connection established and once we create that prototype to the way that we want to, we're going to change that prototype into reading muscle signals from the forearm to do the same movements. And then within this lecture, we're going to be talking about the design and who's going to be benefiting from this. So for this project, our ultimate goal is to really understand how robotics works for the prosthetic arm and how we can combine those two concepts together to make a functioning product for those who suffered an injury or was born without an arm. And unfortunately, that does happen in real life where people don't have the luxury of having all their born limbs. And in order to address this topic, we're trying to learn more about it and try to find different solutions that would work for the beneficiary. And our main goal is just to create a product that is designed to successfully mimic the human hand and make it more of a user-friendly device for those who have one arm and it's supposed to resemble a real arm. So for usability, I want you to take a moment to just look at your hand, flex your fingers a little bit, clench your fist, open it up again. So here's a brief system overview on what we're going to be designing in this class. On the top slide, that's going to be our prosthetic arm. We're going to be connecting an EGN4950C to an Arduino, and then this Arduino is going to be connected to 5 different servo motors, which is going to be our fingers. For the bottom part, that's going to be the wireless glove. It's also going to be connected to an ESP8266, which is connected to the LilyPad Arduino, connecting the flex sensors, and those flex sensors are going to be registering the movements in the finger and translate it back to the prosthetic arm, mimicking the human hand's movements.
Hello, my name is Renato Soto. I'll be providing my group with the 3D printed parts necessary to create the prosthetic hand. In order to create this artificial hand, I will be using my Ender 3 printer that will be used to heat plastic, which in this case is called a filament, to sculpt layer by layer the parts required for this project. Now the filament that we'll be using is a transparent PETG. There are various other types of filaments with different properties such as nylon, which is strong, durable, and flexible. TPE, which is very flexible and rubbery. HIPS, which is biodegradable and dissolvable, just to name a few. PLA is another type of filament that is considered to be easier to print than PETG. Although both are user-friendly, PETG has the normal reputation that it is easy to print as PLA, but it has the properties of ABS. In this case, it's just more durable, stronger, and impact resistant, so it would be a good idea to use for the prosthetic hand. Now for the design of the prosthetic hand, I will be using a website called Thingiverse to obtain the designs. Getting the files for the fingers and palm will be easy, since there are quite a variety of them, but getting the servo housing for them will be challenging. I would have created my own version of the hand, but it would require a lot of 3D modeling experience, which I don't quite have yet. Plus, time is a very limited thing. Upon the completion of the 3D part, it will go down to assembling. The fingers will be connected to the palm, which will then be attached to the arm that will house the motors. These motors will be tugging on a fishing line, which will provide the closing of the fingers, and a separate rubbery line that will bring back the fingers once the motors are not pulling on them.
So as explained in our system overview, the key components that we are going to be using in this project are going to be two ESP8266 modules. Those are going to be our Wi-Fi devices that is going to be connected to one another, creating like a local network. The next one is going to be our Arduino Uno. That's going to be controlling the prosthetic arm. The LilyPad Arduino is going to be connected to the glove, sending signals to the ESP connected to one another. The servo motors are going to be moving the fingers, and then the flex sensors are going to be registering the finger movement via signals and then sending it back to the Arduino, sending it to the ESP to the prosthetic arm. For software used in this project, we're going to be using the Arduino IDE, programming it with C++, JavaScript, and Python.
Kevin Vignes, and for the glove subsystem, we need for the parts, we need the physical glove. We need that because we need a physical glove to put the parts on, and we need the flex sensors because that's what we're going to use to measure how people are moving their hands with the gloves on. Now for the challenges, the big challenges are learning how to use the flex sensors with the gloves, because we don't know how the flex sensors work currently. We're going to figure that out when we make it, or like in the more technical sense, we know how they work in like a general sense. Another thing is attaching the flex sensors to the glove. I hope that's not actually that difficult. I imagine we just like tie it on there and things will work out.
So for the subsystem hand servos, some of the challenges for this part is going to be printing the parts, attaching the motors to the joints, wiring the motors, and programming the Arduino to perform the correct actions. For this part, we're going to need the servo motors to control the fingers. We're going to need the 3D printed hand and an Arduino Nano. So in this slide, we're going to be talking about the subsystem implementation challenges. A few things that we got to consider in this project is the functionality of the glove, how we're going to be giving full control for the user. We have to decide where we're going to put the flex sensors, how these flex sensors work, and at what range we're going to be using that flex sensor when you're contracting your finger using that glove. Another thing to keep in mind are the servo motors in the prosthetic arm, how we're going to adjust the finger due to the movement of the flex sensor in the glove, and how we're going to adjust those servo motors within the prosthetic arm. So for the prototype stages, stage 1 is to create finger movement at least within the first 5 weeks. We're going to have the hand printed ready to go and place the servo motor inside. We won't have glove control yet, but we're going to be using force signals, zeros and ones, moving the finger, moving the servos within the prosthetic arm. Stage 2 is to have the full arm built with all 5 fingers ready to go, and hopefully having the glove established too. We're going to be having this within week 10, having full functionality of the glove controlling the prosthetic arm. And stage 3 is going to be our final build, working on polishing the device, working on little kinks, working out any bugs in the coding, and having our project ready for the deadline. So below is going to be our project schedule, and we're going to try to take advantage of the summer break. During the summer break, we're going to be 3D printing the prosthetic arm and ordering all the specific parts and components that we need for our final design. We're also going to be trying to build a skeleton code just to play with it a little bit. And once we get all the parts in, then we're going to start assembling everything, doing some testing, and focusing on the final submission. So for my responsibilities are to choose the appropriate Arduino or the appropriate microprocessor for this project, trying to find out the different parts that we need for the glove, arm choice, ordering parts, building the schematics and the design, testing out the finger functionality, making sure that the sensors work, building the glove, and making sure that it's aesthetically pleasing for the user.
So let's do a quick breakdown of the responsibility that's going to require my doing. Obviously, as stated before, I will be printing out the necessary components for the hand. Once the prints are complete, the assembly of the hand will proceed. Apart from the construction of the hand, I will be in touch with Chris to assemble and test out the building of the glove and the connectivity of the glove with the prosthetic hand. Once everything is finished, then we will look into making the aesthetically pleasing for the patient that will use the prosthetic hand.
Responsibilities for Ryan Bates is going to be Arduino choice, deciding on the Arduino, ordering parts, writing the code, figuring out the finger functionality, glove control working, and to back up the electrical engineering majors.
Kevin Bigness, and here are my responsibilities. Wanting to order parts that are necessary for me to accomplish our goal. It's like to test things as none of us can really meet in person effectively. Next thing I need to figure out how to control. I need to help make the code to control the hand. I also need to figure out how to hook it up with the glove. Please help with that. And control the microcontroller. So that way the microcontroller can take the information it's getting and have correct responses with the hand. That's it.